students out, am I, Anthony?
You just did.
He didn't even hear me. It doesn't matter then. Nothing, don't worry about it.
He called you out.
Yeah, about right now. Yeah, I heard.
We got different numbers.
Oh, okay.
We got different numbers.
Alright, most of us got different numbers. It's okay to have different numbers. Alright,
You gonna be moving us to school out the year like you moving?
throughout the semester, yes ma'am.
Oh, God.
Okay? Okay?
Did he just say yes?
So, really quickly, so I feel that I understand solving equations better having completed the worked on the MATHia workspaces. Quite a few of us strongly agree, and disagree. So I do want to point out, like, the homework that I assign is never designed to just be busy work. It is designed to help us grow and get better. And I did get a handful of emails last night, and I wasn't able to help a ton with those emails just because I think I got them literally when I was going to bed. I wake up at 4:30, 4:40 every morning, so it's hard for me to respond when you email at 9:30, because even going to bed at 9:30, I get 7 hours of sleep max, which is not great. But overall, I am glad to see that we are agreeing that we understand better. A quick note that I do want to make, though, is even though we are understanding better, I only saw about 6 people out of this class, a class of 28, who have actually completed both modules. So that is, or not both, but the 5 workspaces. Yeah, I think you completed. There was 2 different modules, right?
Oh, okay.
There was 5 total workspaces. There was 4 in the one,
Yeah.
and then 1 in the other, right?
Yeah,
Solving
yeah.
quadratics was just
Yeah.
one.
Okay.
You can still finish it. A quick note that I have, or that I do want to say is, I understand, like, if you were absent all last week, maybe not getting it done. However, don't forget that there's still Schoology and there were emails that I sent out. You got to pay attention to that, and you got to get it done ASAP if you were out all last week. And I saw this for a handful of students, I saw a few students who put in 3 hours of work total and still didn't quite finish the workspaces. If you were that student, I'm not going to count the workspaces late. You put in time, you put in effort, you still need to finish them. But if you put in 3 hours, I get it. For the students, huh?
It would make me mad.
Well, you did more than you were supposed to. You did like 8 workspaces.
I did all 7, because it was 7. And then I did the one of 1.
But one of those was exactly the same as one of those 7.
Oh. Well, at least it's done.
But yeah, it's done. Like that's what I was impressed. But yeah, remember I told y'all you only had to do 4 workspaces from that one, and then yeah. Sorry. Anyways, reach out when there is confusion, questions, things like that. But as I said, if you did 3+ hours of work, I'm not going to count that late. Just finish it so you can get it done and learn from your misunderstandings, things like that. For those of y'all who haven't finished, right? I had some people who had only put in an hour of work. Guys, y'all put in an hour of work in this classroom. So we should have more than an hour done. That means we didn't do anything over the weekend with it. It is an assignment that you have to complete. If you don't complete it, whatever percent you finish is the percent that you have for your homework. If you finish it late, then that's 10% off every day it's late. So make sure you get it done.
How many points was it?
That one assignment, I haven't fully decided yet. I'm going to have to look at what the other assignments are worth and make it equitable. However, what I will say is, some of y'all need to finish those workspaces tonight. We're going to have an understanding check tomorrow on solving equations, just a handful of problems. Callie, can you let Gerald in? A handful of problems on solving equations, and then a couple problems on writing the equation of a line. So you need to study that. You need to make sure you know how to do it. If you finished your workspaces and you want a little bit more practice with solving equations, cool, let's get that done. All right. Gerald, that's not your pocket number. That's not your pocket number. Gerald Fritz, you're number 9. All right, thanks, sir. Thanks, sir. Okay. So there's that. Let's look at the y-intercept question. So we should already have this out. So
Tell him his new seat.
say again.
Tell him his new seat.
Oh yeah, you are in a new seat. Does anyone remember where Gerald is? Gerald, you are in group. Man, I'm missing your name. Group 4. That's actually where you are. Good. Perfect. So I know some of us weren't here. but I see some of us, how many feet it contracts or expands. Notice 0, negative 4.62. I need that in a little bit more context. But notice how those who I see a good bit of information, right? First off, right here, is that a y-intercept? No, that's the what?
Equation.
That's the equation, right? I didn't ask about the equation, I asked for the y-intercept. If we're talking about the y-intercept, and I'm asking you to interpret it, what do you need? You need the
independent variable.
Independent and dependent, right? You need to know the variables. Remember, one of the things I very clearly said is, if you're going to interpret things in context, you gotta know what the variables mean, right? When it comes to functions, what's the first thing you need when you're identifying the functions, or just working with functions? Okay, sometimes slope, but slope is only for what type of function? So rate of change, right? The slope is only for a linear function, right? You got to know your rate of change. When we're working with data, right? What's the first thing you need to do? Man, I know it's Monday morning, but come on, we got to wake up. I'm about to make some of us, not some of us, all of us, get up out of the desk and do jumping jacks if we don't get involved. Huh? Say it one more
If you
time.
want to work with data, then you have to understand variables and context.
Yeah.
Right, thank you. We look at our notes for this, right? So if you want to work with data, you got to identify the variables in context. You got to define them. All right? And so some of us are getting some of the ideas in here. So here's the answers that are closest. But remember what we just talked about, right? The y-intercept is always a what? Starts with a P. A point, right? The first thing you got to do, and make sure you write this down on your sheet of paper. I see a bunch of people staring at me which have pencils in hand, ready to take notes. That y-intercept is a point. And I know we had all different equations here. But Kelsey, what do we know about every y-intercept point? Every single time? Not sure? Did you pay attention when we had this conversation earlier during the bell ringer?
Zero.
The x is what?
0.
0. If you weren't sure of that, you need to write that down. X equals 0 for all y-intercepts. Now, you can memorize that fact, but I wouldn't. Why should we know, and I might draw a little just off to the side, just a small example. Why should we know that the x value is 0 for y-intercepts?
Because it's on the y-axis.
It's on the y-axis.
That's where it's going to start at.
Partially, it's not just where it starts at, because technically, remember, all lines and most functions, go from negative infinity to infinity. So it's kind of a misnomer sometimes to say that it's where it starts, but if you are looking at the y-axis, what do you know the x value about? Or what about the x value? It's 0. It doesn't matter where you are on the y-axis, the x value is 0. And you can just show a couple of examples here. Right next to this statement.
Then you can draw a diagonal line, and then the x-axis will be 0.
Well, the y-axis, the x value is 0, right? Notice there's just a couple of points on the y-axis. It doesn't matter where you are on the y-axis, the x value is 0. That's not something that you should just stare at. This is something you have to know.
That's why I did by itself, and y is equal, so that's what it is.
Partially. So, Anthony, what equation did you have
For what?
for this problem?
F of x equals 0.06589455.
Say it one more time, 0.0
65
x.
minus 0.55.
So, notice, if I substitute a 0 in here, what's anything times 0?
0.
And then 0 minus this would just be that, right? So that's a big part of it, right? So if I look at f of 0, and so f of 0, when the x is 0, that's negative 4.55. That's why that's the y-intercept, because it's 0, comma, negative 4.55.
Oh,
Okay.
so the 0.065 is the slope.
What do y'all think? Would the 0.065 be the slope?
Yeah, because it's basically your M, and M is always your slope.
And it's not just that it's our m, what kind of rate of change does a linear function have? Not just additive, constant additive, right? Right, constant additive. And what's happening between 0.065 and the x they're being?
Multiplied.
And multiplication is repeated
Addition.
addition, right? So that's the thing that we want to remember. This equation is not random. The slope is multiplied by x because that's repeated addition. If I substitute a 0 in here, I'm left with that. And so that's my y-intercept. Everything about the equation makes sense. There is nothing random within equations. There is this form that we have memorized, but it's not just that we should memorize it. There's a reason to it. Okay? Now, and this is going to matter in a second, I do want to say this. If x equals 0 for all y-intercepts, what do you know about every x-intercept?
It'll be
Why don't we 0?
Well, it could be different.
If every y-intercept has an x of 0, what do you know about every x-intercept?
It have
It
y
has a
0.
y.
It has a y of 0. That's going to matter in just a minute, okay? Now, I know we still need to continue. All right, I'm going to use Anthony's equation up here to talk about interpreting these things. 0, comma, negative 4.55. And so I see some people here who talk about negative 4.3 is the feet of contraction, right? Because if I'm looking here, this is my y value, correct?
Yep.
And y was all about feet of expansion or contraction of the
Equation.
concrete.
Concrete.
Concrete, right? But is there anything from that y-intercept that I'm ignoring? Not the sign, huh? Not the negative, because the contraction, remember, is the idea that it's a negative. Come on, look at that point again. What have I not talked about whatsoever?
It's a decimal.
Not the decimal. Say it again.
Exactly.
The x value. Does that x value matter? Yes? When we did slope, look back at slope. For some of us, because we took notes, look back at slope. Did we just look at the y or did we also look at the x?
You also looked at it.
We also looked at the x. When you're interpreting these things, the x and the y go together, right? So, I'm not just going to talk about negative 4.55 when the what? 0 what? Gerald, that runs out, please.
You said what?
0 what? Remember, this is my x. Look back at the context for x. What is it talking about there? The temperature in Fahrenheit, right? So when the temperature is what?
Rising. Well, increasing, decreasing.
70.
Now, hold on a second. I want to pause. When we're talking about changing, we're talking about the what?
The Fahrenheit.
Which concept? Think back on the equation of a line.
The
Feet.
When we're talking about things changing,
your rate of change.
the rate of change, which would be the what?
The
Slope.
slope.
We good on that? So I'm not talking about anything changing right now. Because I'm not talking about slope. I'm talking about this point. When the temperature is what? I think Eli was saying it earlier.
0.
0. 0 what?
Fahrenheit.
0 degrees Fahrenheit. Notice that's x. I've got to talk about my x. It's not changing. It's just x is 0 or 0 degrees Fahrenheit. Anthony, pick up that pencil and write some notes. Thank you.
Miss Kenneth.
Not there. Where it talks about the y-intercept, Anthony. What does the y-intercept represent in this context? So when the temperature is 0 degrees Fahrenheit, what? Guys, it should not take us 25 minutes to get through this bell ringer. We got to get more engaged. We got stuff to do today.
When the temperature is 0 degrees Fahrenheit, the y-intercept, well, no, the feet,
So what is the what?
the concrete.
The concrete has
Expand,
If it's negative, is it
I mean, decrease,
Contract.
no, yeah,
contracting, right? Has contracted. And now I don't need to put the negative because I've already said it's contracted. Contracting means it gets smaller. So it contracted how much?
the number 12,
4.55.
yeah.
4.55.
Don't you
Well,
have to,
whatever
you don't have to
number
put
you
the
have.
negative?
No, you already put contracted.
So, yeah, and that's the thing to remember. The fact that I've said it's contracted has already said it's decreased, which is a negative idea.
Okay.
Yeah. I wouldn't count it against you, but that's more mathematically accurate.
Okay.
Right? So notice it's not random. And I know some of us are like, Mr. Kenny, this is too much work. No. This is what makes math useful. Y'all are used to the simple math where we just deal with numbers, and we've been fine at that for some of us, but math is supposed to make sense out of the real world. Well, then we need to consider these things within the real world. Math is beautiful and it's useful. Let's make it that way. So when the temperature is 0 degrees Fahrenheit, the concrete has contracted 4.55 feet. If you have not defined your variables, it's almost impossible to interpret these things. Now, I know some of us missed some details last week. When we do this another time today, talk to the people within your groups to get help and develop these skills more. So let's get started on our agenda. So please make sure you have that written down so you can use it to help guide your thinking and support your approach on these things. Hopefully the second time around will not take as much time. But as a quick reminder, what is math?
The study of patterns and relationships.
Study of patterns and relationships, right? We've seen some patterns, and I've explained those patterns for how we would write about these things. We need to use those, right? So I will remind you when it comes to being a mathematician, which y'all may not love to hear this, but you're a mathematician in my class, and there is beauty in that, right? So what are the three things we need to do with those patterns and relationships? Notice, describe, and generalize. Looking for all three of those. When you do those, you're going to learn the math better. It's going to be more useful. It's going to be more fun. Notice, describe, and generalize. So I'm going to do a quick reminder back about active collaboration, especially because some of us are dead on a Monday morning. Sometimes you just got to fake it till you make it. There is a beauty for me waking up at 4:40 is that I'm like, I don't know, 4 hours into the day. I'm wide awake.
What are you doing after 4:40?
Work out at 5:30.
Strange.
My dad do that.
Yeah. I mean, when else am I going to work out? The next class at the gym is at 6:45, so I can't really do that because I have to be here to teach y'all. Kyle's like, you don't have to be here. You could totally be late, but no, I'm going to be here because I like to teach. But active collaboration, hopefully we'll finish up lesson 2. We actually need to finish up lesson 2 so we can start this dream job salary task so we can knock that out. And, huh?
What is that?
The next task. It's about linear and exponential functions.
That's the next, never mind.
We'll learn about it. So remember, with active collaboration, right? I hear a handful of students already jumping in and conversing during the whole class discussion, right? I think Ayana, Anthony, Jakila, Kyle, and Sharnavia. I don't know why I struggled on name for a second, but we're there. I've heard them a lot, right? And a handful of other people have jumped in at times. Eli as well, right? But this should not be the only people I hear talking. I have a total of 28 students that I teach. I think I have 25 of us today. We all need to get involved in that conversation. Here's the thing. If you are involved in the conversation, that means you are thinking about the ideas. If you're silent, more than likely you're not thinking about it. You're just waiting on someone else to give you the answer, and that's not how you grow and learn. For those of us who missed a whole week, I get it. We're still trying to catch up. I'm not trying to call you out. Everybody else, though, come on, we got to get involved in this conversation. I am looking for you to do what 3 things in the whole class discussion? Take notes,
Share your thoughts.
ask questions, and share your thoughts, right? You got to be talking in order to get those higher scores, or even to get a 4 on the active collaboration rubric. So you got to share thoughts, you got to ask questions, you got to take notes. You should be able to do at least 2 of those 3. Even if it is asking questions, right? That's great, ask those questions, right? But you also should have some thoughts, especially because during the small group time, you're supposed to be talking. If you talked as a group, will you have some ideas that you could share?
Yeah.
Yes, right? As a group, encourage each other to share the thoughts that you have all come up with, right? It's not just on you, this is what your group has talked about. So share them. It's going to help you develop important skills. But I slightly changed the objectives of this lesson just because I felt like this was a more accurate wording of what I'm trying to get you to do. But I do still want you to use a calculator to identify an appropriate trend line to approximate data, right? So, what do I mean by a trend line?
What did you just say?
What is that?
When they scatter.
Okay, there is scattered data, but what is a trend line? It's a line that's doing what?
Going to each point.
Through the data, right? When that line goes through the data, it is approximating the data, which is also what we would call a linear model, because it is modeling the data. It's going close to those things. So we want to notice a trend line. It literally is a line that is showing a trend. Mathematics is not, most of the language is not designed to confuse. It's straight, it's right there. It's straight up telling you what you need to know. 2, we want to be interpreting key features of a linear function in context from the function's equation. What are some key features that we might be interpreting? The y-intercept. What else?
Slope.
The slope. And if we talk about y-intercept, we might also want to talk about the x-intercept. Not just the x value. You said x value, which is a part of it, but x-intercept. That's a little bit different, right? Kyle's about to get angry. She's like, I said that, Mr. Kenny. Gotta be careful of that language, right? X-intercept is a little bit different. Alright, so we looked at this idea of the construction project. If you are super confused on it, I understand, talk with your small group or watch the videos. Remember, I posted videos every single day last week. And I posted things on Schoology, which I haven't updated for today, but I will update that at some point, probably during lunch. So here's where we are. Use the linear model to determine how much 1 mile of concrete expands at 110 degrees Fahrenheit and how much it contracts at 0 degrees Fahrenheit. Show your work below. Man, I need to update that question. You'll find out why later. Calculate and interpret the x-intercept of the model. Now, I want you to take 60 seconds to come up with ideas on your own, the important information or ideas about how we would tackle these problems, right? So go ahead and pick up a pencil and write things down. But I want you to take 60 seconds to think about, hey, what do I need to keep in mind? What do I need to think about when tackling these problems? I'm going to give you 2 minutes after that to talk about that with your group. Let's get those ideas down on the paper. 60 seconds on your own, and then time to talk in your small group.
Wait, okay, first of all, 110 degrees in Fahrenheit and how much in context at
It contracts
Oh.
at 0 degrees Fahrenheit. Now, I should say how much it contracts. But y'all, please remember, 60 seconds to just write ideas down. Think key ideas that we should pay attention to for both of these questions. 60 seconds on your own. On your own for 60 seconds. Then we're going to talk in a small group. So just ideas on your own. I want you to individually think. Who said what? Huh? Oh, that's not good. Yeah, come on, wake it up. So you need to stand it up to wake up. But Brittany, you missed a whole week of school. Yes, you're going to be lost. We're doing our best to get you caught up, but you can't get frustrated when you're out for a week. I see some of us not even thinking about the x-intercept question. Come on, there's an important detail we want to keep in mind with that x-intercept. All right, our minute is up. Start talking about it. Think about some ideas we need to consider. You got 2 minutes to get started on this problem. Then we'll have a quick whole class discussion. Come on, you can't fall asleep. You already did this, which you need to tell me a little bit more. And I will point out, you shouldn't say f of x if there's no x here. But I also want you to think about the y-intercept.
the country.
Come on, I need you to start talking. I know you have ideas because I've seen your work. I need you to share your ideas.
I mean, it's
Just all of them.
Me too.
and like in the graphic and the evaluation, like the data and the
Well, and I'm more just focusing on like, what do you need to pay attention to, or how would you approach tackling this first one, right? So how would you tackle using the linear model to determine how much 1 mile of concrete expands at 110 degrees Fahrenheit? Also, the second one, this is almost more important, what are some key ideas to calculate and interpret the x-intercept? Right? So y'all definitely think about that x-intercept. Come on, why are you talking about it? Why don't you have any ideas now? How about you take some notes or put some ideas down so that you can show me you've actually thought about it and then you can fix it if we made mistakes. There's plenty of space there to fix it.
You could have copied it. You don't need it.
Are you looking at the x-intercept or the y-intercept? You sure about that? Because this was the y.
That'll be the best answer of sleep.
Yeah, and it's easy.
That's not an x-intercept. What do you know about x-intercepts? Alright, so I know that we're not completely done, but I do want to go ahead and start talking about this problem. Share out some important ideas that we want to keep in mind about how we could tackle using the linear model to determine how much 1 mile of concrete expands.
Let me try.
Well, hold on, I'm going to let you try in a second, just because, you've already talked a lot. I need other ideas from other students, and Allie's got her hand up, and I want to respect that. What you got?
Like the variables, the variables.
Okay, so we need to keep in mind variables. What was that last part you said?
In the equation.
So like what they mean in the equation?
Yeah.
So do I need the equation here, you think?
No, not as much as like
Yes, you do.
you do, but like you need like what's in the equation.
Yes, but I mean I need the equation, right? So we all have different equations. I'm going to use Anthony's just because I don't remember what mine was, but I would probably write down the equation here. I would just do f of x equals 0.065 x minus 4.55. You need that equation. Now, I also want to point out, I didn't say using the equation. I said using what? What am I calling this right now? Linear model, right? There was a trend line that we created, and this is a linear model, literally meaning it models the data. So you might want to make a note to yourself, because I don't think I've hit on this very heavily. This is my linear model. It's modeling the data. Right? That's why we said record the linear model up here. And yes, Anthony, I know it's a lot of writing, but you need these notes down to use them later.
So how are you supposed to do x? So you need to say that concrete.
We're not there yet. Just hold on. Alright. Does anyone have any other ideas we want to share before Jakayla jumps in and shares her ideas?
It ain't no ideas. I actually did some, but I thought she was asking.
But just explain how, explain what you were thinking about. Not what you actually did, but what you were thinking about to get there. Now, I want to pause for a second. I've already interpreted slope up here, right? And I've already interpreted the y-intercept here. And I have this equation, but do I necessarily need to just focus on slope at this point to figure out how much 1 mile of concrete expands at 110 degrees Fahrenheit? No? So Jakayla, just what were you thinking? Like what were you thinking about in order to tackle this?
Your variables, because it's with the 110, basically it's telling you to just insert it in where x is. So
Oh.
you just using.
How'd you know that 110 is supposed to take the place of x?
Because it's asking how much is the mile concrete expanded, and with that we had said that the slope intercept, I don't know how to put it in words. I knew what I was doing, I just don't know how to put it in words.
Now I want to pause for a second because I hear this all the time. Do we fully understand if we can't put it into words?
No,
No, you got a good idea to get it started, right? But we got to make sure we're working on that language. If we can't explain it, we don't fully understand it, which we need to pause on that. Does anyone have another explanation now hearing that Jakala's like, hey, I'm going to substitute that 110 in for x, right? So why am I substituting 110 in for x?
Because it say temperature.
Because it says temperature.
yeah, that's what yeah.
Like you said.
See, that's why you can't separate me and Anthony, because then he know what I be trying to say.
Input variable, right? The x was my temperature in degrees Fahrenheit. You should already have that note. So if we are dealing with 110 degrees Fahrenheit, this can take the place of
Eggs.
x. That's an x value. Oh, okay. So notice, can we just look at or can we ignore interpreting the variables in context?
Mm-hmm.
No.
Wait.
You cannot ignore the interpretation of the variables in context.
No.
That's like, you knew where to substitute that in because, hey, I know that that's degrees Fahrenheit. So what about this 0 degrees Fahrenheit right here?
That's the, so now
You
we're
can
talking
use
about
that one.
x-intercept.
Yeah, it's just gonna give you the same
The
answer.
x-intercept.
So
Which intercept?
Why?
Okay, so this is still an x value for y-intercept, which is why I need to change this question, because we've already done that.
So I got a question, Ms. Kim.
Yeah.
So now, we got the problem to plug in. Now, do we just calculate it?
Yeah.
Get the x-intercept?
And they give you the different.
No, not the x-intercept. We're gonna get to the x-intercept in a second.
You get a different answer for the one with the 110, but you're gonna get the same answer
From
for the
up
0.
here, and that's why I need to change that question. But I'm gonna have you do that within your small groups. Okay? Oh man, it must be really hard, Kyle, to pick up a calculator.
Oh, no.
Okay. Calculate and interpret the x-intercept. Now, I kept hearing Anthony talk about putting that 0, or talking about this point here. Is that an x-intercept?
No, that's a y. You
That's a
put
y-intercept.
You put the 0 at, the y-axis to make it
Not y-axis, y
value.
value.
Y value.
So when we're talking about an x-intercept, we know that y is equal to,
Y is equal to m less plus b.
Yeah.
no, not for an x-intercept.
0.
Oh.
For an x-intercept, what do we know?
It's 0.
The y is always 0. So is that an important piece of information we should pay attention to?
Yes, I gotta write that down.
Thank you. The y is equal to 0 for all x-intercepts. That's a key idea we've got to pay attention to. You can again look at an axis, an x-axis for that information. Okay. Now, I want to pause, and I do want to point out, Destiny, in this equation here, do we have a y?
Oh.
No? Do you know of anything that could be the same thing as y though?
Zero.
Well, the y is equal to 0 for the